Let's talk about interest and exponential growth and exponential decay. Now, in order for growth to be exponential, you have to have a quantity changing by a fixed amount or a fixed percentage each time period. We can model exponential growth with this formula, where big A is the amount in the account, say, after t time periods. Little a is the initial amount. R is the rate of growth or the rate of decay, and T is the number of time periods. Now I want to talk a little bit about the rate. A lot of times we give rates as percentages. So if I say it's growing at 5%, then I don't want to put 5% in my formula. I will put it over 100 or put it in decimal form. Now, if I am adding interest, all right, whenever I talk about interest, my rate is going to be positive. Now, whenever I talk about depreciation, the rate is going to be negative. So, suppose you invest $1,000 in a savings account at the end of 6th grade. The account pays 5% annual interest. How much money will be in your account after 6 years? What you need to do is write down all of your variables. The 1,000 is your initial amount. $5% is your interest. Now go ahead and put 5% and then convert it to your decimal. How much money will be in the account after 6 years? So my time period is 6. For my students, I want to see the formula. So write the original formula. And then substitute in. So A is 1,000. Don't bother putting your units in here. 1 plus R is 0.05 to the 6th. So this is 1,000 times 1.05 to the 6th. Now you're going to need a calculator for this. And when you do, you get $1,340.10. Whenever you're dealing with money, remember always take it to the penny. Now, suppose you invest $1,000 in a savings account that pays 5% annual interest. If you make no additional deposits or withdrawal, how many years will it take for the account to grow to at least $1,500? This one's a little different. Let's start writing down what we have. You invest $1,000, so little a is 1,000. And it pays 5%. So R, now we've done one of these, so we can go in and just write it as 0.05. If you make no additional deposits or withdrawals, how many years, so we're looking for time, for the account to grow to $1,500? So my big A is 15. Again, I want you to write out the formula. A is A, 1 plus R to the T. Now substitute in 1,500 is equal to 1,000 times 1 plus 0.05 T. Divide both sides through by 1,000. 1.5 is 1.05 to the T. Now obviously for this problem, you're going to need to solve this. You can do a table. We will learn how to do this with logarithms. But for right now, we're just going to use the magic of a calculator and find that T is about 9. Now, another way we do interest problems are when things are compounded annually or monthly or weekly. So this formula is very similar, but what do you do when it's compounded at different time periods? Well, A is your amount accumulated. P is the principal amount or the initial amount. R is the rate, again in a decimal form. The difference here is N is the number of times it's compounded per year. And so this is just a very interesting formula that is very handy, and yes, I do want you to have it memorized. The easiest way to explain this one, I personally think, is to do a few problems. Suppose you have a bank account whose principal is $1,000, and your bank compounds the interest twice a year at an interest rate of 5%. How much money do you have in your account at the year's end? Well, let's see. The principal is 1,000. So P is 1,000. It's compounded twice a year. So in this case, N is equal to 2. An interest rate of 5%, so R is 0.05. How much money do you have in your account at the year's end? So A is P, 1 plus R over N to the NT. So my principal amount is 1,000. 1 plus the rate is 0.05. N is 2. And this is to the N, which is 2. And the time is 1 year. Forgot to write that down. So this is 1,000 times 1 plus 0.025 squared, 1,000 times 1.025 squared. And when you do that, you get 1,050.63. All right, so what if you start a bank account with $1,000? So the principal is again $1,000. And your bank compounds the interest quarterly. So quarterly means 4 times a year at an interest rate of 8%. So my rate is 0.08. How much do you have at the year's end? So at the end of 1 year, the time is again 1. So the amount is the principal times 1 plus the rate divided by N to the NT. So this is 1,000 times 1 plus the rate is 0.08 divided by 4 to the 4 times 1. So this one is 1,000 times 1.02 to the 4th. So this answer, with my handy dandy calculator, gives me, pen's not wanting to work, $10,824.32. Now, let's look at this one. The first credit card you get charges 12.49%. So there's my rate, and it's 0.1249 to its customers and compounds that interest monthly. Well, there are 12 months in a year. Within 1 day of getting your first credit card, you max out the credit card, by spending the limit of $1,200. So my initial amount, my principal amount is $1,200. If you do not buy anything else on the card, which is really good because you max it out, and you don't make any payments, which is bad because you need to do that, how much money would you owe to the company after 6 months? Okay. Now, the time here is 6 months out of 12 months, or a half a year. So the amount is the principal times 1 plus R over N to the NT. Now the principal is $1,200. 1 plus r is 0.1249 divided by n, and n in this case is 12, to the n, which is 12, times t, and in this case t is, I'm just going to write it as 1/2. So this becomes 1200. Let's do what's in the parentheses. This becomes 1.0104 to the 6th. So my answer is, when I multiply this out, $1,276.92. So basically what this tells you is the amount of interest you're going to pay in this 6 months is 70, we'll write this down, is going to be $76.92.